In today's lesson, we are looking at division of polynomials, and it's basically a review from Algebra 2. So we are reviewing long division and synthetic division. Okay, so here are two polynomials that we're going to divide. So let's set it up for long division. Okay, so this goes underneath. So I have 6x to the fifth minus x to the fourth. Notice how there is no x to the third term. I need to put that in with a 0x to the third plus 12x squared plus 15x, and then I'm going to even add just plus 0 to kind of show that we're missing a term at the end as well. Okay, and then we're dividing by this polynomial, so 3x to the third minus 2x squared plus x, and I'm going to put a plus 0 just to remind us that we're always looking for those missing terms, and you have to put a 0 in. All right, so let's get started looking at the first terms there. 3x to the third goes into 6x to the fifth how many times? Or you could just think dividing. So I'm going to divide, and I will get 2x squared. And now I need to multiply and bring down. So multiply out here. So 2x squared times 3x to the third will give me that 6x to the fifth. And then 2x squared times negative 2x squared would be negative 4x to the fourth. And then plus 2x to the third. And then plus 0x squared. And then subtract. So the first terms will always cancel. So negative 1 minus negative 4, so that goes to 3x to the fourth. 0 minus 2, negative 2x to the third. 12 minus 0 plus 12x squared. Bring down the next term, plus 15x. Okay, let's look at the coefficients here. 3x to the fourth divided by 3x to the third is simply just x. And now multiply x out here. So x times 3x to the third becomes 3x to the fourth. X times negative 2x squared is negative 2x to the third. X times x is x squared. And then x times 0, 0x. Subtract. So these cancel. These actually also cancel. 12x squared minus 11x, or minus x squared is 11x squared. And then 15x minus 0x, that is just 15x. And then in theory we would bring down, but we don't need to in this case because plus 0 doesn't affect everything. And I'm basically done because 3x to the third does not go into 11x squared. So this is my remainder. So my answer is 2x squared plus x, and then with the remainder, 11x squared plus 15x. But remember, how do we write remainders? We always write it as a quotient of the remainder over the divisor. So 2x squared plus x plus 11x squared plus 15x over 3x to the third minus 2x squared plus x. All right, the next example, I'm giving you a fact here. So x minus 3 is a factor of this polynomial. That means if I divide this polynomial by x minus 3, I'll have the remainder of 0. And then what our goal is to we're going to completely factor this cubic polynomial. So what we're going to do is divide it and see what's left over. So let's set this up. 6x to the third minus 25x squared plus 18x plus 9, and I'm dividing by x minus 3. Look at the coefficients. 6x to the third divided by x is 6x squared, and then I multiply. So 6x to the third minus 18x squared Negative 25 minus a negative 18 is negative 7. And then bring down. And then look at the coefficients. Negative 7x squared divided by x is negative 7x. And then multiply. So negative 7x squared plus 21x. Subtract. These cancel. 18 minus 21, negative 3x. Bring down the 9. And then look at your coefficients. Negative 3x divided by x is minus 3. And then multiply, so negative 3x plus 9. When you subtract, there's our remainder, 0. So what we've done is basically shown that, x minus 3 times our answer, 6x squared minus 7x minus 3, gives us this polynomial. So what we're going to do is continue factoring. So we've factored this, and now can we factor what's left over? So this is x minus 3, and then if I factor here, I'm going to break the 6x into 2x and 3x. Break up the negative 3 into 3 and 1. I'm going to put minus 3 here, plus 1 there. Double check. This gives me 2, and this gives me negative 9, which would give me that negative 7. So this right here is fully factored of the original polynomial, and all we had to know is that this is a factor. Okay, now we are going to review synthetic division. Synthetic division is kind of nice. It's organized really well, and it's pretty quick. It's only convenient when you're dividing by like this binomial where the leading coefficient is 1. If the leading coefficient is higher than 1, you can still do it, but there's more steps to it, and at that point you might as well just do long division. So synthetic division. Here, if you look at x plus 2, if you think about where would the 0 be on a graph, it would be at negative 2. And you kind of just put it up in this little box. And now we have to write the coefficients off to the side. So I've got the coefficient 2. Look at your exponents. 4, we're missing exponent 3, so that would have a coefficient of 0. And then negative 5, 5, negative 2. So we're just writing the coefficients of the polynomial, and the first coefficient comes down. Now, we are going to be multiplying. Negative 2 times 2 is negative 4, and then we add 0 plus negative 4 is negative 4, and then multiply. Negative 2 times negative 4 is 8, and then add to get 3. Negative 2 times 3 is negative 6, and then add to get negative 1. Negative 2 times negative 1 is 2, add to get 0. So when you have a 0 at the end, that's your remainder. And now you're going to, this negative 1 is the constant. We're going to put in x squared, x to the third. So when you divide, your answer is 2x to the third minus 4x squared plus 3x minus 1. All right, so last example, another synthetic division. Minus 3, that means there's a 0 at positive 3, so that's the number that goes in my box. And then coefficients, 4, 3, negative 1, and 8. And I'm not missing any terms, so 4, 3, negative 1, 8. Bring down the first one. 4 times 3 is 12. 12 plus 3 is 15. 3 times 15 is 45. Negative 1 plus 45 is 44. 3 times 44 is 132. Add those together, you get 140. So that is your remainder. And then this is your constant. This would be x. This would be x squared. So 4x squared plus 15x plus 44, and then plus the remainder, 140 over x minus 3. So there is your video reviewing long division and synthetic division. Good luck.